Hello, this is Sean McGowan doing my video submission for Lab 7, Stepper Motors. In this lab, we're using our Arduino and H-bridge to rotate our stepper motor at different speeds, directions, and increments. Here I'm using two AA batteries and a 9-volt battery to make a 12-volt power supply for the motor. In my initial code, I have an input function which asks the user for which motor mode to activate. If a value of 1 through 8 is entered, the motor will act out the corresponding function. So to start off, we had to find how many steps per revolution our motor produced. We found this by applying our step formula we can see here, 2 times the number of phases times the number of pole pairs. I found on the data sheet that the motor I had 4 phases as well as 4 north-south pole pairs and a gear ratio of 64. We then multiply the number of phases by the number of pole pairs times 2, which gives us 32 steps per revolution, and then we multiply it by 64 to get our 2048 steps per revolution. In our 360-degree rotation loop, we divide our 2048 by 4 and run our loop. The direction of the motor is determined by the order of which pin is set high. For forward, we set A high, then B, then A bar, and then B bar. And if we want it reversed, we just do the reverse order of pins set high. So we'd start with B bar set high, then A bar, B, and then A. To change the speed of the motor, we change our integer V for speed. This V determines the amount of time in the scale of microseconds in between setting each pin high. So for faster rotation, we use V is equal to 5,000 microseconds, and for a slower rotation, we use a longer time of V is equal to 10,000 microseconds. Next, we were to have our motor complete a whole revolution in increments of 45, 90, 180, and 360 forwards and backwards. We already completed the 360-degree revolutions in the first part. We accomplished these increments by dividing the 248 in our loop to decrease the amount of steps the motor will take. So when we enter 3 for F, we will go forward in 180-degree increments. Our 240 will be divided by 8, which will half our full 360-degree rotation, and then we complete the loop 2 to the F minus 2 times to complete the whole revolution. This continues for our 90-degree increments of F is equal to 4, where 2048 will be divided by 16, quartering our 360-degree revolution, and 45, which divides the 2048 by 32, thus cutting it into 8 increments. The process is the same for the reverse direction, except the order of pins set high is the reverse order of the forward directions. This video is showing my implementation of the code into the motor. So by typing our input of F, 1 through 8, we do a different mode of our motor, sending it forwards, backwards, we change the speed, and then we set it to do increments of 45, 90, and 180 in the forwards and backwards directions. So I'll let the rest of this video play out. That is it for the lab. I hope you enjoy, and I will see you next week.